Okay. Starting out with a combination of all the congruence theorems for triangles. And we must state if the two triangles are congruent, and if they are, I must state how I know. And there are 18 such questions. 18 questions. And so I'll get started now. Okay, so for this triangle here, angle, so yes, because angles, two sides in common, and this angle over here. So yes, that is the, how do you exactly say this? I mean, this, these, wow, okay. I would think so. This one I know for sure. This is angle side angle. I guess I don't actually know that for a fact for this one, but we'll check. Okay, so we don't actually know that these are congruent. And here's why. Here's why. Here's why that's wrong. Because, like, I guess it's because they look so congruent, and perhaps they were actually intentionally set up that way that it fooled me. But anyway, the point is it doesn't follow one of these procedures. So no. Okay, so for this one here, yes, this is a side-side-side theorem. For this one here, these two angles are congruent because they're vertically opposite. And that's the angle side angle theorem. And so yes. And we check. And that's correct, and that's good. Here, nope, we don't have sufficient information. We just know that they have one matching side and one matching angle. We don't know. For this one here, there's a pair of vertically opposite and therefore congruent angles, and so it follows the angle side angle theorem. So yes. Correct. Side angle side, but not the case here. So no. Side to side. So yes. Okay. Vertically opposite and therefore congruent angles. Side angle side. Side to side. And that's all correct. State what additional information is required in order to know that the triangles are congruent for the reason given. Okay, so angle side angle. We would have to know that this angle here is congruent to this angle here. In other words, angle TUD is congruent to angle SUT. For the side angle side theorem to hold, let's see. Okay, these match. So I would have to know that edge XK is congruent to edge WV. Check. Correct. Note, when I name angles with 3 letters, I follow the anti-clockwise convention or counterclockwise convention, naming convention. Okay, side angle side. I would have to know that side CA is congruent to side LJ. Angle side angle. I would have to know that side DE or line segment DE is congruent to side or line segment JK. Check. Correct. Side angle side. I would have to know that side JI is congruent to side TS. Angle side angle. I would have to know that angle MLK is congruent to angle STU. Or I guess they named it by a single letter, but that's totally fine. Yeah, and that's correct. For the side-side-side theorem, to congruence theorem to hold, I would simply have to know that side RS is congruent to side QD. For the side angle side theorem to hold, I already know that these are congruent angles as they're vertically opposite. So I would have to know that side WV is congruent to side VM. And we check. And that's correct, and that's good. And now for right triangle congruence. We need to learn about this. Let's take a sip. Okay, there are 18 questions, so it's all okay. State if two triangles are congruent, and if they are, state how you know. Okay, so that appears to be a straight line, although I guess I don't know for sure. And if that is the case, then yes, by the side angle side theorem. However, I don't know that that's the right angle, it just appears to be. For this one here, no, they're not No, they are. I'm just being silly. I mean, they have to be. That has to be equal to that. I guess I don't really understand what they're asking for. So I guess I should see. Okay, so they say LL and HL. So I need to know what these acronyms mean. Interesting. Never heard these terms before. I mean, I guess it's a different. LL, HL, LA, and HL. What? Okay. Of course, I know what a hypotenuse and a leg is on a right triangle, but I kind of took this knowledge as intuitive or just sort of automatic. Hypotenuse leg, hypotenuse angle, leg, leg angle. All right, we'll give it a shot. Okay, all right, okay. So this one here, for example, that would be the, assuming that that is a right angle there, that would be the leg theorem. Leg congruence theorem. Leg congruence theorem. And I guess this one would be the hypotenuse leg theorem. And we check, and that's correct. Okay, this is good. Yes, these are congruent by the hypotenuse angle theorem. So it goes hypotenuse angle, leg angle. Okay, hypotenuse angle, yes. I wish they would mark in that's, I mean, that's vertically opposite, so I already know. But it's kind of an, hypotenuse angle theorem. That's correct. Hypotenuse angle again. No, we don't actually know this for a fact. These could just be similar and very, very, very slightly scaled. So we don't actually know that for a fact. They are similar though. Good. There's no indication that these are right triangles or right angle triangles. And they don't follow any congruence patterns, so I would say no. Okay, so this is the leg theorem. And you can see that that is a special case of the more general side angle side theorem. Okay, that's good. These angles are congruent because they're vertically opposite, but we don't know that the triangles are congruent. We just know that they're similar. Both of these are right angles because they're vertically opposite. And by the side angle side theorem, which in this particular case will be the leg theorem, they're congruent right triangles. And that's correct. State what additional information is required in order to know that the triangles are congruent for the reason given. For the hypotenuse leg theorem, well, I guess I would have to know that side HV is congruent to side FD. And for the leg theorem here to hold, I would have to know that side AC is congruent to side VX. And we check. Okay, good. So they say that there are two cases confirming what I thought, but I didn't actually articulate it, to be fair. Side DE is congruent to side VW. Notice, by the way, that I care about the order of the endpoints when I'm naming the edge. Okay, so for the leg theorem to hold, I would have to know that side HM is congruent to side LM. For the hypotenuse angle theorem to hold, I would have to know that the hypotenuse NM is congruent to the hypotenuse DC. And we check. And that's good. For the leg angle theorem to hold, I'd have to know that that angle there is congruent to that angle there, and I'll just name them by single letters right now. or B is congruent. Angle B is congruent to angle J. That's another possibility. For the hypotenuse angle theorem to hold, that no, I mislabeled that. That wasn't a misunderstanding, it was just misspeaking. Okay, that's good. Next up, for the hypotenuse leg theorem to hold, I would have to know the length of the hypotenuses in the first place. So in other words, I'd have to know that the side ED is congruent to the side JI. And for leg angle theorem told, I would just have to know that side FE is congruent to side VE, or that side DF is congruent to side TV. And I check, and I check, and that's good. That's good. Okay, so isosceles and equilateral triangles. That's what's coming up. So X is 7 units long. X is 6. X is 6 as well. And X is 4. Just check these. Seem a little bit too 7, 6, 6, 4. Okay, that's all good. Here, the measure of angle X is 70 if you like, but check. Good. Next up. Okay, so that'd be 65 there. That'd be 50 there, 50 there, 50 there. And X would have to be 80. X is, 28 is there. So, all right, so that means 62, and that would be 62 as well. Add them to get 124, take that from 180, and you get 56. Check that. Good. Okay, so we have to find that big, massive angle there, knowing that that angle there is 148. So that means this little angle here is 32. Split that, take that from 180, you get 148. Divide that by 2 and you get 74. Okay, 74 there, 74 there. And do 90, take 32 to get the complementary angle here. And you get 58. That's 58 as well. And I mean, we already have x now. $122. Though I do want to know what this is. That's 64. So that whole angle there is 138, huh? Okay. We need to find what x is, and x is down there. So that's going to be 60. So this is an equilateral triangle, in fact. And yeah, I think it'll be 60 all the way. So we'll check. Good. And now, well, those will be of equal length. And if that's 8, and if -1 plus x is equal to 8, then x is 9. Equal angles, equal sides. These are right triangles as well. Side angle side theorem, they're congruent. So 12 is equal to 2x take 12. So x must be 12, I guess. Okay, that's fine. Okay, that's good. Find the measure of angle 2. You're told that the size of that angle is x plus 94. Okay, well, this is isosceles down here, so that must be 47 as well. And so must that be, and so must that be. And then 47 doubled is 94. Take that from 180, and we get 86. So x at 94 is... Isn't it? 47 times 2 is 94. Take 94 from 180. This is not good rushing. Take 94 from 180, you get to 86. There you go. Okay, find the size of angle 2. Well, that's 68. Double that. 136. So that's 44 right there. And so angle 2, complementing that, must be 46. So 46 is 4x take 2. So 48 is 4x. So x is 12. Check. Correct. Good. Okay, that's 118. Oh well, find the supplement to it. So 62. So 62. So 28. So 28. And double 56 and take from 180. And you get 124. So x must be 10. And now find the measure of angle 2 right there. Okay. So 180 take 146. That's 34. That's 34. That's 34. Vertically opposite. That's 34. And take that away and you get 146 as well. And hold on now, just a second. That's equal to 13x at 3, right? So take away the 3 and you get 143, which means that x must be 11. And we check, and that's correct. And that's good. Okay, be well, be well.